How many of you use DRS in a production environment? Whoa, I guess almost everybody here. Thank you very much. Thank you for your confidence in the software, and thank you for your continued support of my employment. My name is Ann Holler, and along with my co-speaker Ganesh, we've both been working in the DRS team since 2006. We've worked in all areas of DRS, DPM, and storage DRS, worked in design and implementation, worked in fixing bugs, and also handled the, hopefully, knock on wood, occasional escalations into engineering of problems coming in from support in the field. And so we wanted to talk today about some of the experiences we've had, particularly in that last category of problems, in terms of unusual advanced scenarios in which DRS has been used, and some of the things we've seen there around performance and capacity planning, tips we hope will help you if any of these things should arise in your environments. So from the very beginning, DRS had 4 design goals. The first was to optimize the performance of the VMs running in the infrastructure in accordance with the resource controls that you set. Secondly, to allow sharing of resources between VMs, but isolation between a group of VMs when that's desirable. Thirdly, to use the infrastructure efficiently, that is, to use the infrastructure as much as possible for running the VMs and as little as possible for the overhead associated with managing those VMs. And the fourth was to provide a comprehensive resource management and cluster system that would handle all sorts of things such as business rules and the maintenance of the infrastructure in a seamless way. So it wouldn't just be about CPU and memory resource management, it would be about all the tasks you need to do when you're managing a set of VMs on a set of hosts. The mechanisms we use to try to achieve these design goals are providing automatic placement and load balancing for VMs, enforcing the QoS around VMs based on the settings and based on resource pool structure that you defined in your cluster, enforcing policies that you've set on your infrastructure, VM to VM rules, VM to host rules for affinity and anti-affinity, and finally handling automatically things like host maintenance mode by evacuating hosts. So here we see a VM moving to another server for load balancing. So how do we use these mechanisms to achieve these design goals? There's 4 ways we do this. The first is to compute and deliver the resource entitlements in terms of CPU and memory that each VM in the cluster deserves based on their current usage, the resource controls you set on them, and the configuration of the VMs. Secondly, we manage mapping the cluster resource pool onto resource trees on individual hosts so that then ESX can manage the VMs for those mini trees on each host. Thirdly, we model the vMotion remediation costs. This is trying to help us handle efficiency. We don't want to spend your resources that you want to spend on VMs moving the VMs around unless you're going to get some benefit from us doing so. And fourth, we handle a series of constraints that are important to you when you're managing your infrastructure. Basic constraints like, is this VM compatible with this host? And more advanced constraints like constraints around the way you've set HA settings, constraints around the host state, like a host being in maintenance mode, and constraints around your roles. So let's look at how we use these elements to achieve these design goals and see what can unfortunately go wrong or can be a little bit difficult to manage in advanced situations. And by the way, a bunch of these tips will be around setting advanced settings in DRS. These, in some cases, aren't the default way that DRS works. And this is the screenshot of where you would enter these DRS advanced settings for these scenarios when they involve using advanced options. So let's start with the way DRS is computing and delivering VM, CPU, and memory resource entitlements, and what are some challenges and tips around those challenges. To start with, as you probably know, DRS treats the cluster of a set of hosts as if it were one giant host. So in this example, there's 6 hosts in the cluster. Each of the hosts has 10 gig of CPU and 64 gigabytes of memory. But DRS treats this as if it was one giant host of 60 gigahertz and 384 gigabytes. This is important because it means the VM gets what it's entitled to as if there was no host boundary. So it doesn't matter which host the VM is currently on. We're going to figure out what resources it's entitled to based on all the resources in the cluster. And doing this, figuring out what resources it's entitled to, depends on resource controls and demand. So let's look at those 2 areas. Resource controls that are provided for VMs and also for resource pools include reservations. That's how much a VM is guaranteed to get. So in this picture, the VM has an 8 gigabyte memory, and its reservation is 1 gigabyte, so it's guaranteed to get 1 gigabyte. Limit is a guaranteed maximum on how much resources a VM can get. So in this example, even though the VM was configured for 8 gig, it's only going to get 6 gig because the person has set a limit, and it won't get more than that. In between reservation and limit, the VM gets its demands fully satisfied unless there's contention. And if there's contention, the shares are used to resolve that contention to figure out how much this particular VM deserves. So in this case, the VM got 5 gigabytes. That either means its demand was 5 gigabytes, or it means its demand was bigger than 5 gigabytes, but there was contention, and given the shares, this is how much the VM got. So as you can imagine, the trickiest part of all this is demand. Where does this demand metric come from? So let's start with CPU. So with respect to CPU, as I said, the entitlement in CPU will be equal to the VM's demand unless there's contention. We start with the demand estimate that ESX computes for a VM. So ESX is computing the demand for a VM based on how much CPU the VM got to use, and how much additional CPU it would have used if that additional CPU hadn't been stolen from that VM. So what is the nature of CPU being stolen from a VM? There's 4 categories in which you could consider the CPU that this VM wanted to use having been stolen from it. The first category is ready time. This VM was ready to run, its vCPUs were all ready to go, but the pCPUs, the physical CPUs, were busy running somebody else's job or some other part of the infrastructure. That's called ready time. The second is overlap. That means the VM was running, everything was good, and then an interrupt came in and was serviced on one of the physical CPUs that this VM was using. And in fact, that interrupt wasn't for this VM, it was for some other VM. So this VM got a little sidetracked and had time stolen from it to handle something that was on behalf of another VM. The third area in which you could consider CPU time being stolen from this VM is for hyperthreading. So hyperthreaded CPUs, in a hyperthreaded model, the CPUs share certain parts of the physical CPU real estate so that if multiple threads are running in a hyperthreaded situation, there is more contention than if they were running without sharing in the hyperthreading. So that's a little bit of CPU stolen from this VM. And finally, power management can steal CPU from this VM. And by power management here, I'm talking about power management enabled at the BIOS level. So beneath the level of ESX, where ESX and the rest of the infrastructure doesn't realize power management was turned on, and that power management may turn down the frequency of the CPU. DRS takes this demand metric that ESX produces and computes a derived metric over time. The reason for this is that DRS runs at a much coarser granularity than ESX, and it needs a much coarser and more long-term estimate of the CPU's demand. Basically, for load balancing, DRS looks at the last 5 minutes of demand as reported by ESX and takes the average of that. And for cost benefit, which is DRS's way of evaluating whether a move is worthwhile, not only because it improves the load balance, but because it also looks like a good move given the way the demands are varying over the last 60 minutes, looks at the maximum over that extended period of time. And DPM also looks at an extended period of time to decide whether or not to power down hosts, whether it's really worthwhile. So, as we said, CPU demand is satisfied unless there's contention. And one of the key ways people look at contention is ready time. How many of you manage ready time or look at ready time and monitor it in your infrastructure? Okay, looks like at least half of the people, half of you do. Yeah, I do too, basically. So kind of the rule of thumb is that if that ready time should be below 5% or 5% or below per vCPU. And so, for example, if you have a 4 vCPU VM, then your ready time for that VM should be under 20%. And this example, I drove ready time up by introducing contention in the infrastructure. So I had a VM. That purple bar is how much CPU it was able to use. This dark blue line, or I guess light blue line, is the ready time. So at the times when I induced contention, the ready time jumped up to way above 20%, and the usage dropped because the VM was having a lot of CPU stolen from it due to ready time. Now, I should say that high ready time isn't always a problem. The ESX scheduler has a NUMA-aware feature where if your host has NUMA, it may be that the ESX scheduler wants to bias your vCPUs to keep running on the same set of physical CPUs in order to make sure it gets the NUMA memory quickly. So it's making a trade-off between, scheduling you more quickly or making sure that when you do run, that the VM gets quick access to memory. So that's a trade-off, so it's not always bad to have high ready time. But certainly we have seen several situations where people were having high ready time when it really was a problem. And I know those of you monitoring ready time are doing it because you have seen problems when ready time is too high. So let's look at 2 examples of situations where ready time was an issue and what they turned out to be. Okay, the first one was the customer had high CPU ready, the VM was performing poorly, and he did a manual migration and it fixed the performance problem. How many of you, if any, have had this happen to you? Okay, not as few as I would hope, but certainly at least less than a dozen, but a dozen unhappy situations. Okay. Yes, so at least for this customer, when we looked into this problem, we figured out, and DRS thought things were fine. DRS wasn't recommending any moves. Obviously, a move was needed. The person moved it and it was good. So what's the deal? And also, DRS is considering ready time as part of that ESX estimate of CPU demand. Well, in this case, what we found was the workload was very spiky. And DRS is using that 5-minute average of demand that we talked about. So in this picture, that sort of dark blue line is what the 5-minute demand that DRS was using. And that green spikes was the actual little spikes that the VM was experiencing in CPU usage on the host over time, on CPU demand. And so basically, by taking that 5-minute demand metric, we were smoothing out those spikes and missing them. And so DRS wasn't doing the right thing in this case with respect to making sure that design goal of VM performance was being maximized. So for 2013 release, vSphere 5.5, we've introduced an advanced option that you can set aggressive CPU active. This means that instead of taking that 5-minute demand as the demand metric, it takes the maximum of either that 5-minute demand or basically the 80th percentile of the 1-minute demands. So this is giving us a much more, I guess you would say, conservative way of catching these spikes. We didn't make that the default because we know you guys don't like us changing the defaults in dot releases. But basically, if you're having a ready time issue and you want to kind of enable this option, I think this will help a lot for these situations. Okay. The second ready time problem we had, and we were just mystified by this. Unlike the first case, there was high ready time just like the first case, but unlike the first case, there was no contention, there was no obvious problem. The CPU on the host was lightly loaded. The host in general was lightly loaded. And it took us a while to figure out the problem here. But basically, it was that fourth category of stolen time that I talked about on the ESX demand metric slide, which was that basically host power management was enabled below the level of ESX. And so basically the BIOS was reducing the frequency of the CPU while the VM was running, and basically the VM wasn't getting the amount of CPU that ESX had intended during its scheduling. And basically to fix this problem, you go into the BIOS and you change the power setting to OS control. What this does is say, ESX, you manage power, and therefore ESX knows when frequency and voltage are changing because it's the one changing them. It does it in accordance with being able to deliver the CPU and memory that VMs expect. So this basically fixed that problem. Have any of you guys had this problem where the BIOS power management was interfering with? Okay, so probably a lot. This actually, I guess for at least the last 2 years, this has been one of the most common support calls into VMware support according to the support guys. So yes, sorry about this, and yeah, please, I wish there was a way we could detect this, but please check on this if you're having a problem. All right, that's CPU. Let's turn to memory. So basically, memory storage is very much like CPU. We start with the ESX estimate of memory demand. So ESX estimates memory demand using a statistical technique called 1 minute active over the last 4 minutes. So basically, it does the following. It looks at the pages that are mapped. It unmaps a random sample of them. It waits a minute and sees what percentage get mapped back in. So for example, it would choose 100 pages, should be a small, not noticeable percentage that wouldn't impact performance. Runs for a minute. If 50% of them are mapped back in, it says, oh, then it must be, demand must be 50% of the mapped pages. That's the way this works. It has special stuff for large or swapped or ballooned pages. DRS, kind of like in the CPU case, takes this demand metric and looks at it over an extended period of time. For load balancing, it looks at it again for 5 minutes. And again, for cost benefit and DPM, it looks at it over a max of the last 60 minutes. There's one difference between memory and CPU, though, which is that in addition to using this metric in this way, we also add some headroom to the load balancing metric. So we add a 25% headroom to that metric. And the reason we do this is that memory is very costly to reclaim from other VMs. And so it's just a lot more important to be conservative about how you estimate demand because reclamation and mapping really has a much bigger impact on VM performance. Right now, we take 25% of consumed idle. What does this mean? Here we have a 5 gig VM. So let's say at boot time, the VM touched all its pages, so 5 gig is mapped in. Let's say that ESX memory demand computed by DRS averaged over the last 5 minutes is 1 gigabytes. We take that 1 gigabytes plus 25% of that remaining 4 gig that seemed to be idle but is also consumed. So DRS would consider the demand of this VM to be 2 gigabytes. Okay, what can go wrong? Well, okay, so the VMs will get all their demand unless there's contention, just like in CPU. And people typically monitor contention for memory by looking at ballooning or looking at swapping. How many of you monitor ballooning and ballooning first, ballooning in your, so a lot of you, probably 2/3 of you monitor ballooning. Anybody monitoring also swapping, or your life is over if you swap? Okay, yeah, pretty much everybody, probably 2/3 of the people are monitoring swapping, yes. So basically, ballooning doesn't have to be a problem. It could just be that the VM doesn't really need that memory and it's not a problem. But it can be a problem. So in this example, again, I artificially introduced some contention. So this VM was getting a lot of mapped memory in the red. I introduced contention on the infrastructure. The blue showed the balloon inflating, and then the memory that the VM was able to map got reduced, took the contention away, the VM was able to get memory back. So in this particular case, the ballooning caused internal guest swapping, not a good story, so the performance of the VM was substantially impacted in this scenario. So what can go wrong? Well, what we found is some people have experienced that the demand estimate was lower than they desired. Let's look at an example here. This was a customer who basically had an important VM move for memory reasons when that move did not seem very useful or appropriate to that customer. Why is that? Well, DRS had added in that 25% idle on top of the demand estimate of the VM, But the customer said, look, I'm managing my infrastructure so that all my VMs are fully backed by physical memory. I'm not doing any memory overcommit. So, you know, why are you, DRS, managing to this active plus the idle when that's not interesting to me? I'd like to tell you how much above active to use, and I'd like to tell you to keep 100% above active preserved for this VM in terms of considering it to be the VM's demand. How many of you are actually managing to make sure that your VMs normally get 100% of their memory backed by physical memory? So maybe about 10% of you, okay. Yeah, so for folks like you, VMs moving around due to active, that's not interesting to you. And so you may want to use this option. Again, we didn't make it the default because a lot of different people manage their clusters differently. As you can tell, some folks are doing a little bit of memory overcommit. It looks like most folks are. But if you're not doing memory overcommit, you certainly don't want VMs moved around for this reason. You can set this option in vSphere 5.5%. Megabytes in memory demand. Instead of being default 25%, you can jack it up to as much as 100% if you just want to make sure the DRS knows you'd like demand to be considered all, you know, the full mem size. There's also a way to set this in previous releases. It's a little bit backwards. I mean, we've had this since the beginning of time, this other advanced option, but it's not very well designed because no one had ever used it. In fact, this only came up within the past year, which is kind of interesting. But anyway, this other option kind of does the same thing, but you need to flip the sense of it. If you set it to 75, which is the default, it adds in 25% of idle. So, and the old option only influenced load balancing. This influences it. Yeah, sure.
Sorry. For memory reservation, what I do is reserve 100% of the memory machine.
Okay.
Does it have the same effect as this new option?
Yes. Well, here's, oh, it has almost the same effect. So the question is, I already, because I want, you're saying because this person wants to have their full memory backed by physical memory, they set reservation to 100%. And does this do the same thing, or does this do something different? That definitely makes sure the VM always gets 100% of the reservation, but it means you can never overcommit, even temporarily. Like even if you wanted to put a host in maintenance mode or something, and you had that reservation, it might prevent you from doing so. This sort of does that. This says this is demand. But demand can be violated if there's contention. So this is a little bit softer than what you're doing because this will let us put a host in maintenance mode and not completely satisfy demand. But as long as there are enough resources, this will satisfy demand. It's kind of a softer version of what you're doing. But that's good input. I think that also works for sure. Okay. This was problem number 1 where we got an undesirable memory imbalance. Did anybody else have undesirable imbalance moves where you, well, yeah, we already know that some of you don't want to manage this way, so this will be good. All right, let's keep on going. Okay, memory entitlement problem number 2. This is related to problem number 1. How many of you use DPM? Anybody use DPM? All right, what, 2 people, the green people that are here in the audience today. Okay, one complaint that we had, and maybe some of the rest of you, how many of you tried DPM, but you thought that it consolidated memory too much? Okay, this is good to know. Okay, a couple more people. Yes, so we got this feedback, and again, we were taking the maximum of the memory demand over the last hour, so we thought we were being conservative, but that's not that conservative if your VMs are completely idle overnight, because they're going to have very low demand overnight, but when you come in the morning, it's going to be sluggish to get their pages mapped back in. So basically, that same option that I mentioned in the previous slide, when it's set, and now it's by default set to 25%, that says DPM will also leave headroom. So by default now, with this option, DPM will by default leave headroom in vSphere 5.5 to keep from consolidating too much. And you can change how much more headroom that DPM would use to avoid this, swimming pool situation while you're using DPM. So go ahead and try DPM again if you tried it before and it consolidated too much on memory. But yeah, this has also been a challenge for DPM, and I'm glad to hear that some people are using it anyway. Yes? Yes. Okay, interesting. So the question is, there was a problem with DPM not respecting the soft rules that you were using for a stretch cluster. That is, please see me after this talk. That was not the intent. Certainly soft rules can be dropped if it's absolutely necessary to drop them because the consolidation is too high or for some other reason, like they're violating some hard constraint. But they weren't intended to be dropped for a DPM. So this is we need to look into this. This is not good. Thanks for that, sharing that. Okay, at this point, I'm ready to turn over to my co-speaker, Ganesh.
Thanks, Anne. So first, I want to talk about resource pools and some options to tweak them. So resource pools help you manage groups of VMs. You can group VM as a single entity and set policies on them. You can say that these are my Hadoop VMs. I don't want my Hadoop VMs to take more than 25% of my cluster. How many of you use resource pools in your cluster? Well, okay, that's more than half of you. As you probably know, resource pools have the same settings that you can set on the VM. You can set reservation, limit, and shares. Reservation and limit are absolute units that are basically the minimum and maximum for the resource pools. And shares are relative priorities that you can set. And when there is contention, the resource pools would get resources proportional to their shares. So in this example, RP1 and RP2 would get resources in the ratio of 150:400. And whatever resources RP1 gets, it'll give it to the VMs in the ratio of 2:1 when there is contention. Okay. So let's see how resource pools work. So let's consider just resource pool RP1, and it has two VMs. Let's say the VMs are on two different hosts. Actually, on the host, RP1 would be split, or RP1 would be copied, and each host would have its own RP1. And VM kernel also understands resource pools, and it is the one that actually enforces resource pools in a very small time granularity. Like every few milliseconds, it would ensure that the resource pool constraints are met. But because the VMs are on different hosts, DRS would set these resource pool settings on host A and host B, and it would change it periodically. So for shares on the host, DRS basically splits the shares depending on how much shares are entitled by the VMs on each host. So on this, in this example, VM1 deserves 2/3 of RP1's resources. So RP1 on host A gets 100, which is 2/3 of 150. Similarly, RP1 on host B gets 50. Now, DRS also splits the reservation and limit. In this example, the reservation is 500 and limit is 8,000. And DRS splits them by taking into account the reservation, limit, shares, as well as the demands of the VMs. So if you have the VM1 totally active and VM2 is totally idle, then VM1 can get bulk of the 500. So because VM2 has a reservation of 100, VM1 can get up to 400. So in this example, the reservation is split as 200 and 300, and the limit is split as 3,000 and 5,000. And when the demands change, these numbers will also change. So let's take the example of when VM2 increases in demand and VM1 decreases in demand. Then DRS would move resources from RP1 of host A to RP1 of host B. And by default, DRS does this in a very conservative way. DRS doesn't move the resources too fast, because if RP1 on host B does not, like if the host B does not have enough resources to take the new setting, then DRS might have to do some vMotions. And to avoid large number of vMotions, DRS moves the resources in a very conservative way. But if you have a lot of resource pools in your cluster, or if you're using vCloud Director's allocation pool model, then you might have run into some scenario where DRS did not move these resources in a timely manner, and you feel that the VMs are suffering. How many of you use vCloud Director's allocation pool model? Okay, that's 2 or 3 of you. And have you ever run into the situation where you set a limit and you feel that the VMs are not getting enough? Okay, so we have 2 options in 2013. The first option is to make the reservation flow much more aggressively, and the second option is to flow the limits more aggressively. If you set these options to 1, then what DRS would do is, whenever you have a spiky behavior and one VM becomes idle and another VM from the same resource pool becomes active, DRS would move the resources to the active VM much more aggressively. The second thing I want to talk about is modeling vMotion costs. DRS has a lot of smarts to figure out what would happen after you do the vMotion, and a lot of the smarts is built in the cost-benefit filtering. So by default, before doing a vMotion, DRS does a cost-benefit analysis. When you move a VM, the VM would get more resources on the destination, probably because it's less loaded. The source host now has more resources available because it has one less VM to contend with the other VMs. But the destination host has one more VM. DRS takes into account all these things and figures out what's the net benefit of moving this VM. Then DRS considers 2 costs. The first cost is the cost of doing the migration. vMotion itself has some cost, both in terms of CPU and memory, and both the source host and the destination host would have to pay this cost for the duration of migration. DRS also considers a risk cost. DRS considers this move based on the current demands, and demands can change drastically. So after doing this vMotion, if the VM demands change drastically, and the move might not be very useful because of this change, or worse, the DRS might have to move the VM back because the source host has all the VMs, suddenly they drop in demand, and now the destination hosts, they increase in demand. So to avoid this scenario, DRS considers a risk cost, and if the VMs are very unpredictable, then DRS would add a higher risk cost. So by default, DRS gives a little bit of a free pass whenever it does a migration. Every vMotion has a cost, but by default, DRS does not consider all the costs. Now, when you have some VMs in your cluster that are very latency sensitive, and if you move them, you feel that the workload inside the VM is being affected, then there is an advanced option you can use to make DRS consider all the costs in the migration. This is useful if you have latency sensitive application like VoIP or database that dirties the memory a lot. When this option is set, DRS considers the actual cost of migration. It considers how long it will take based on how actively the VM is dirtying the memory, and it will try to, because it considers a higher cost, those migrations will be throttled more. Do any of you have run into the situation where you feel that DRS is moving too many VMs, or because of DRS migration, the workload inside suffers? Okay, so 5, 6 people have run into this. By setting this option, you can reduce the number of moves, as well as DRS would make sure that it doesn't move the bigger VMs. So in 2013, we also have this option called as latency sensitive VM. You can mark a VM as latency sensitive. And when you do this, ESX would treat the VM differently and would get the VM the resources it wants more quickly. DRS by default soft affines the VM to the host on which it's running so that it doesn't move the VM that is latency sensitive. There is another feature in 2013, which is the vFlash, and DRS soft affines the vFlash enabled VMs as well. This is because when you vMotion a vFlash enabled VM, the SSD cache moves with it by default. So when you do a normal migration, it actually does the normal migration as well as it does the storage migration of the vFlash disk. And because moving the cache can be expensive and it might take longer time, DRS soft affines the VM on the host on which it's running currently. So we talked about how to tweak cost benefit so that you can reduce the number of moves. But sometimes the opposite scenario might happen where even when you make DRS more aggressive, you might feel that DRS is not moving enough VMs. Has any of you run into this situation where you feel that DRS is not moving enough VMs? Okay, about 10 to 20% of you. So we introduced an option in 2012 wherein if the cluster becomes severely imbalanced, we drop the cost-benefit filter. There is another filter called as min goodness filter where DRS tracks how much benefit there is when you move a VM. And if this benefit is lesser than a threshold, DRS will not do the move. When the cluster is severely imbalanced, the filters are dropped. But then you can also tweak these options. If you use the options in the bottom of the screen, then DRS will drop the filters even when there is slight imbalance. But this might actually cause too many moves in the cluster, and the moves might not have enough benefit. So please use it with extreme caution. The recommended way to make DRS more aggressive is to use the slider, and you can set the DRS settings to be more aggressive. Next, I want to talk about constraints. One of the major functions of DRS is to respect various rules that can be used as building blocks to specify various business requirements. DRS has different types of rules. You can specify affinity rules between VMs. You can specify anti-affinity rules between VMs. Now you can specify affinity or anti-affinity rules also between VMs and hosts. You can say that these group of VMs should run only on these group of hosts, or these group of VMs should not run on these group of hosts. You can also make a rule between a VM and host soft. What this means is that the group of VMs would be on the set of hosts as much as possible if it's an affinity rule. But if the VMs need resources and that can only be got by moving the VMs to another host that's not in the affinity set, then DRS would do it. DRS might also break the rule to satisfy other rules, or if a host is going into maintenance, like one of the hosts in the affinity set is going down for maintenance, and DRS cannot do that operation unless it has to break the rule and then move the VM to another host. If the rule is marked as soft, then DRS would do that. So consider an example for using the soft rule. If you have an asymmetric network or storage cost, in this example, you have two data stores, and let's say they are running NFS. If you have a VM on the rack on the left accessing, but its disk is on the data store on the right, then every I/O has to go through the core router, and maybe the bisection bandwidth is contended. So we can set a rule that says that VMs whose disk is on the left data store should run only on the left rack, and VMs whose disk is on the right data store should run only on the right rack. Only when DRS cannot satisfy all the VM demands by satisfying this rule. DRS would move it across the bisection bandwidth to the other side. We can consider a more extreme case where you have a stretched cluster and you have half the cluster on one side and the other half of the cluster is on the other side of the WAN. Maybe there is storage replication and you have a local data store for the machines. Even if you can move the VMs to the remote host, it may take very long and the move might be very expensive. One of the use cases that was brought to us was something similar, and the admin wanted the VMs to move only for maintenance or other emergency operation. In 2013, we have added an option to make the soft rules semi-hard. What this means is that when this option is set, DRS would not violate the soft affinity rule for demand to satisfy demand. Even if the VMs don't get what they want, the rule would not be dropped. But only for mandatory moves where like you have a host going down for maintenance or to satisfy some other rule, this rule would be dropped. Apart from the rules, there may be some use case where admins might want to restrict the number of VMs onto the host, maybe to restrict failure impact or not to put too many eggs in the same basket. DRS load balances to make sure that all your VMs meet the demand and they can also spike in the future. But you might have a lot of idle VMs, and in some cases, DRS might be able to consolidate a lot of the idle VMs into smaller number of hosts. But if this happens, then you might have too many VMs on a single host. In vSphere 5.1, we introduced an option to limit the number of VMs per host. If you set this number, say 6, then no host in the cluster would have more than 6 VMs. This is a pretty hard option because this constrains DRS heavily. So in 2013, we introduced another option where you can specify the variance in the number of VMs per host. So let's say on average you have 20 VMs per host. If you set this option to 20%, what this means is that DRS would allow 20% more than the mean, which is 20 on any host. Yes.
Not possible to set it per vCPU?
No, it's not possible to set per vCPU. This is just the number of VMs per host.
Do you have different size hosts in your cluster?
No, it's more interesting to limit the vCPUs because the running times. There can be VMs one CPU or with vCPUs.
That's good feedback, yeah.
Yeah, that's good feedback.
Yeah.
So next, I want to talk about capacity management. One of the questions we get asked is how many VMs to power on in a cluster? So the first thing to consider is not to over-reserve the cluster in terms of reservation. DRS does have admission control, and it will not allow too many VMs to be powered on such that the reservation is violated. So the admission control is done both at a cluster level and at a per host level. But some unreserved capacity is needed in the cluster to do vMotions. Like vMotion tries to reserve 30% of a core, and if it cannot get this, vMotion does proceed, but it proceeds at a much slower pace. ESX also needs some unreserved capacity to do its normal operations from time to time. It needs it temporarily. And overhead is also considered as reservation, and some VMs might want to grow their overhead. And if there is no unreserved capacity left in the cluster, then the VMs cannot grow its overhead at all, and that might have some performance penalty. So it's actually very important to make sure that you don't over-reserve the cluster. It's recommended you don't reserve more than 75% of your cluster capacity in terms of reservation. So if you go to the resource allocation screen of the cluster, you can see how much of the capacity is reserved. So for memory, this number includes the reservation as well as the overhead of the VMs. So one of the big benefits of vSphere is to overcommit resources. You can create as big of a VM as you want, and there is a little bit of a penalty to be paid in terms of overhead, but overall it should be fine to overcommit as long as your demands are lower. So let's say you have a cluster with 10 GB of memory. You can run VMs whose mem size sum up to even 100 GB as long as the cumulative demand is lesser than 10 GB, say 8 GB. The main thing to look for when sizing DRS cluster is the peak demand. If you go to the cluster utilization page, you can find the cumulative demand of the cluster. And if you take the maximum over the last, let's say, 1 month or so, that should give you a good estimate of how much the demands are in your cluster. For CPU, you can look at active, and for memory, you can look at the active guest memory. And that's actually the cumulative number for your entire cluster. You can compare this with the capacity of the cluster, and if this is lesser than 80%, then all the VMs should get what they want. When this number gets closer to 100%, and it gets that sum of demand gets beyond 100%, then DRS has to throttle some VMs, and it throttles the unimportant VMs, basically the VMs who have low shares, or it will throttle all the VMs when all of your VMs have equal shares. How many of you use shares for your VMs? Okay, that's like 10%. If you are overcommitting your cluster in terms of demand, then it's probably a good idea to set shares. So one other thing to look for in this page is to look at the swapped and ballooned. So if you have a lot of swapped memory, then it's bad because the performance of the VM might go down a cliff and the VMs might suffer. Ballooning is not always bad, because if you have ballooning and the guest is not swapping internally actively, then it shouldn't cause performance degradation. And if you see a lot of swapping but no ballooning, as is shown in this example, then it means that a lot of the VMs don't have the guest driver. So it's a good idea to check to make sure that all the VMs have guest drivers so that they can use ballooning instead of swapping. So what are the things that can go wrong? Like if you see vMotion becomes very slow in the cluster, one of the reasons might be because there's not enough unreserved capacity in the cluster. If you don't have enough reservations, VM might also fail to power on, especially for memory, because even if you don't set reservation, the overhead is considered as reservation, and without sufficient unreserved capacity for the overhead, the VMs won't power on. So now we can answer any additional questions that you have.
Is there a complete list of advanced options somewhere?
No, but we should probably create
That's good feedback, yeah. Where would you like to see the list? Would you want a KB or?
Yes, it's like the HA options.
Okay,
Okay.
Like that, that's great.
Okay.
okay, good, thank you.
Hi, for VSphere 5 and 5.1.
Oh, there's a mic, where's?
Sorry, I've got the mic at the moment.
Okay, shout, we'll repeat the question.
Okay, so for 5 and 5.1, you had Duncan Epping's clustering deep dive book, which explains most of these quite clearly.
Yeah, there is.
How about VMware, do a similar documentation yourselves so we don't have to pay.
Okay, good feedback. So VMware should do something like what Duncan does to provide this kind of a follow-up to your question about documentation. Okay, yeah, thanks. Okay. Oh, wait.
Hi there. Just wanted to clarify, did you say that DRS includes CPU ready time calculations before it makes moves, decisions?
Yeah, so the question is, does DRS include CPU ready time calculations?
It does, because ESX includes them in its demand calculation, but we think that these ready time issues really are coming about because we're underestimating demand given the spiky workloads. Are there other things you're looking for us to consider?
No, I've just had a scenario where I think there was a number of VMs with very high CPU ready and they weren't being distributed to even that out. So I'm sure DRS was doing all good things, but in my mind, it wasn't looking at CPU ready at all to make moves. I was just surprised when you said it takes into consideration the ready time.
It was such a big disconnect. We always thought we were considering ready time because it's part of the ESX metric. But then we had customers like yourself saying, it's not moving things. There's a lot of ready time. I have to move them manually. It's broken. And so we hope this option to avoid clipping those spiky workloads fixes the problem. And we probably make this the default once we're at a more major release. But we would be very interested if it doesn't fix the problem because there's something else going on that we need to understand. Either this or the power management thing, which I assume you're not having that issue. So, yeah, please let us know if this doesn't fix the problem. Yeah. Okay, thank you very much.
Thank you.